Now we're going to transition over to David's main presentation, inspection and testing. So, David, if you want to share your screen, mate, or a great podcast, great insight, let's carry the conversation on through your presentation. I'm really looking forward to being a passenger and seeing what you can bring to the table, mate.
That sounds great, mate. Well, look, let's get into it. I'm pretty sure I have control here at the moment. So thanks for everyone that's joined online tonight. This is really timely because our inspection and testing specifically services is something that we've grown so much over time, right? Through that curiosity that I talked about that before, that drive to deliver value. And it's recently been something I've looked at and said, wow, we do so many different things. And I'm pretty sure that almost all of our clients only know about 20% of them.
Yeah.
And that's on, us to communicate this a little bit more and see where we can actually contribute value. So, little bit of an overview about waterproofing integrity. Like we discussed, we're coming up to our seventh birthday. Now we've done a lot in that time. The originating idea was actually quantitative testing services. At the point in time, there were always independent consultants that would come out and throw out their opinion, and they would often vary wildly. We wanted to be something that was measurable and quantitative. So we built it around these types of tests, and we sort of grew over time to try and give a bit of an independent voice on is your system good enough? And nothing against the material suppliers or the waterproofing contractor, but when push comes to shove, there is a motivation there to get the job done. And we just thought we want to be an independent voice to help get those long-term outcomes, right? So we're currently a team of over 60, I think maybe a bit closer to 65 at the moment. Our office is based in Sydney, Newcastle, Brisbane, and Melbourne, but we sort of work nationally at the moment, a little bit of work in New Zealand from time to time as well. We've done a huge amount of projects to date, and we want to continue doing that. And the thing that I'm most proud of recently is that we've achieved our NADA accreditation, which is an accreditation for the quality of our testing services. It proves that we deliver a testing service that's defensible, standardized, consistent. We want anyone that relies on our service to um, have confidence that those results are above reproach. Um, and yeah, so we're very happy about that. And it's not for all of our services, but it is for the core ones, and we'll continue expanding that accreditation, right? Um, a few of our other associations and accreditations on the left-hand side there that we're very proud of those.
Just one sec. Can everyone see David's screen?
Yep.
Yeah. Awesome. I'm just making sure because I sort of can't.
Good
There we go.
stuff.
Now I
Lucky
can.
I finished my
Sorry, mate.
fancy intro. Okay. So, what we're going to run through tonight, I've tried to break it up because there are quite a lot of different things to discuss here. Broke it up into three different areas. So, we're going to start out with the basic test methods that a lot of you guys are probably familiar with, but we'll talk a little bit about them anyway. Then we'll go to advanced testing methods, and then we'll go into diagnostic, which is fault finding and whatnot. So, starting out with basic. Uh, this one's one of the most obvious ones, right? And it's definitely a hot topic with the new requirements coming in with the NCC 2025. Previously, we had 1 in 84 requirement for internal wet areas. That's now been expanded to all wet areas. So checking our falls, so obvious. One of the most common ways of doing it is with a spirit level, particularly a digital spirit level. And that's why I put that one there. Not too much scientific about it, but it gets the job done. What I want to uh, foreshadow, I guess, with this next slide here is something we're looking at. And I don't want to talk about too much in detail on the technology yet, but this is something that I'm looking at adopting in order to help everyone deal with the NCC 2025 that's going to have these large external areas. How are we going to be able to do it? We don't want to be running around rooftops with digital spirit levels trying to check every angle and everything like that. How do we know that we're going to be achieving that 1 in 80? Well, there's technologies out there which we're evaluating at the moment for the best angle on it that can do scans of all of these areas with enough accuracy that you can plot and lay out like shown on the screen here, and even do it in an augmented reality style where we aim to be able to give our clients a file or a link where they can walk through the site after we've done our scans and actually say, oh, okay, yep, I can see exactly where the low point is here. Let's implement a fix for it and so on. Or maybe there isn't any issues and it's just good quality control that you can give to your certifier and say, hey, you know, that new clause that we've got to satisfy in the NCC, here's our proof that we've done that. So we're still figuring out exactly how we're going to approach, but keep an eye on that one because it is going to be a challenge for these
Just
projects.
one sec, mate. I apologise. I've got one person that said he can't see your slides. I'm just going to go to the majority. Can everyone see David's slides?
Yeah.
Yeah. So Darren, you might have a more thumbs up. So Darren, it might be a setting on your computer, mate. I apologise, David.
No worries at all. Okay, so yeah, that's focus on achieving falls, which is a hot topic right now. Uh, then we go into surface moisture testing. Another quite simple and obvious one. Everyone should be relatively familiar with these devices. They are moisture meters that are calibrated to a conductance based on a specific type of material. So this is quite interesting. If you're not, this doesn't actually tell you how much water, how much H2O molecules there is, right? What it does is it's calibrated in a lab and it says, okay, when there is this amount of moisture, the electrical conductivity will read this much. And then they make the device read on that, right? So this is an indicative relative device, but that doesn't mean it's a bad one. It's still a very good thing. You just have to be a little bit wary of it if it's calibrated for concrete, and then you go and try and use it on something different, like a screed with a different density, different mixture. You can't be as confident that those moisture readings are actually going to be correct. Doesn't mean it's not a great device. Everyone should be using this.
So David, on that topic of moisture content, we're now. I know you do a lot of scope reviews and design specifications, etc. There's a hesitancy across, or a lack of consistency across manufacturers about what is suitable moisture content to apply a membrane on. Where we used to see it commonly listed, and now it's either not listed or you have to do some deep diving or request specifically from the manufacturer about what a suitable moisture content is prior to installing the membrane. Why has that shift happened?
I, not being a materials manufacturer myself, can't give an exact answer for that, but I do feel like there's a lot more caution and hesitancy about making commitments to things that could result in a liability outcome, right?
So how do we navigate that?
How do we navigate? I think we have to twist arms a little bit, right? If they're, the material supplier is responsible for these sort of things, right? How can we install a product if they don't give us reasonable parameters that it's supposed to perform under? And I think it's a shame, but it's the reality of it that everyone is wary, and the understanding might be, well, let's just not be forthcoming. Let's wait
Yeah,
until they force us to do it, then we'll give the information. And if that's unfortunately the way of the world because of the caution around this, then I think the advice I'd give everyone is don't hesitate to force them to give the information. And
100%.
also value the material supplier that is more forthcoming and is more helpful and is prepared to put their neck on the line a little bit to help you as an installing contractor get the job done the way you need to.
Definitely, and you want to lean on the manufacturer to support you. Okay, so if you haven't got the information that you need to lean on it because there's plenty others who will provide it for you to you.
There is. We need to create that bit of a competitive marketplace on you
Definitely.
help me with this because it's a reasonable expectation, or I'll find someone else that will. And then everyone, the bar gets lifted in expectation. Okay. So off the back of that one, if the previous one was an indicative, then what this test is intended to be a lot more accurate and precise. This test, and it does use a similar Tremex meter, but it actually connects to a probe that's embedded down inside the concrete. And that probe actually tests humidity, which is a direct measurement of moisture content, right? So this is a lot more reliable. The test standard for it is ASTM F2170, great standard that tells us how to do this test. And it gives much more concrete, much more reliable results. So probably a lot of you are thinking, well, when do we do the previous one versus this one? And it's the same answer I'd give in a lot of scenarios is if it's more risky or the outcome consequence is higher, then you use the more stringent and more costly. It does take more time to drill into the slab and insert a probe and everything like that. But you're going to get better outcomes and be discerning about when you need those better outcomes because it's going to help you get a better outcome, better confidence in your result, or potentially protect you from a future liability.
Definitely. And you need to be taking photos of these stages of the process. Document holistic portfolio of evidence.
Yeah, you're right. There's no point doing great degrees of quality control if you can't prove later that diligence that you went through.
So, you're rocking up, you might get involved really early in a project life cycle, and then you're rocking up to check membranes, maybe doing substrate inspection, but let's just say testing membranes after the fact. If there's contractors who are out there and they're able to provide you with a portfolio of evidence of the stages leading up to you guys getting there, does that help make your job easier?
It definitely does. Like we aren't on site all the time. One of the things that we want to do is get an understanding, the lay of the land, what's going on as soon as we get there. And sometimes things are concealed and we don't have an understanding and we have to apply a degree of skepticism in those scenarios. So the sooner that we can get information that helps us get up to speed and then focus on solving the real current problems and providing value that's relevant to that stage of the project, that's what we want to be doing. So definitely helps.
Yeah. I'm just going to mute you there, Rick. Carry
Cool.
on, Dave.
So looking at this one here, the controlled flood testing. Now, this could have easily fit in under the diagnostic section, which we're going to come up to later, especially with this photo here. This is obviously doing a diagnosis of a completed system. But flood testing is something that happens still very commonly for good reason as a construction stage quality um, measure. Now, fun little takeaway on this one, why I wanted to include it in here, is that there is actually a standard. It's an American standard, but nonetheless, it's a standard that can be followed. ASTM D5957 for controlled flood testing. So if anyone's interested, I'd say have a bit of a look up for that, see if how you've been doing your flood testing aligns with this. Because whenever you align with your standard, it takes away another party's ability to scrutinize why did you do it that way. Okay, so the reason I put flood testing there was it's the OG, right? The original way of what we call continuity testing. The whole purpose of it is to check that your membrane, which is supposed to contain water to a certain area, is in fact containing that water in that area, right? And I explain this because electronic leak detection, and we are going to talk about quite a few different types tonight, starting off with the simplest version. But all types of electronic leak detection work through the exact same principle. However, you're not containing water, you're containing electricity, right? You apply a current to the surface of it, almost all waterproofing membranes are non-conductive. So when you apply a current to the surface of that membrane and you connect your earth lead into the conductive substrate below, if the waterproofing system is continuous, no breaches, there should be absolutely no way for that electrical circuit to complete and set off an alarm on the device, right? However, if we apply the test, and in this one, it involves a broom with metal bristles that you pass back and forwards over the membrane. If at any point that circuit does complete, that means you have a breach at that location, right?
Yep.
The thing that I love about electronic leak detection is that you know instantly. And especially with this type of ELD, the waterproofing isn't wet. You don't have to wait for it to dry. You can patch it if the waterproofer is kindly supporting the test. You can patch it immediately, sign it off immediately. As soon as it's dry, you've got a compliance system. Flood testing, you got to wait for it to leak. You got to figure out, well,
Yeah.
where did that leak come from? Everything like that.
So it's a good point you make. Um, and flood testing not conclusive. People think it's the be all and end all. It's one method. Um, and one of the situations that I tend to educate people on is that a flood test in a liquid membrane scenario might actually pass at the initial stage of construction where the membrane is actually being installed too thin. And then during the life cycle of the building, so we have cyclic movement, we may see the membrane fail due to this cyclic movement because the membrane hasn't been installed to its optimum capacity. So it's passed the flood test, but during the life cycle of the building, a year or two later, we've got an issue.
Yeah, yeah, I'd actually add to that by saying, imagine this scenario. You've got your structure is like a nice solid sky-on sheet, or even a good reinforced concrete structure. Waterproofing's been done. If I walked in there with a box cutter and did a big slash down it, I didn't go over any joints or anything like that, but a big slash and did a 24-hour flood test. You think that'd have a fair chance of still passing a flood test?
Yeah, I would have thought so. And a lot of people, a majority of the leaks that we see are from penetrations and terminations, not necessarily on that flat open substrate. In that particular scenario, it would definitely happen after a few days, but it may pass a 24-hour flood test.
Yep. We've
I do
actually
want to
done
give
it
it.
to test it out, and it does. Over time, of course, the waterproofing gets under there, the water
Yeah,
gets under, delaminates from the substrate. So
yeah.
it's not a good indicator of long-term performance.
No, I would agree. And I do want to give a shout out. This looks like an install from Rick Murray's team at Newcastle Waterproofing because it's a tremendous sheet install. It's what you want to be rocking up to when you're a builder.
Very well could be. Okay, what do we have next? Actually, I should have played this while we were talking. This is
You
just
got
a
the
little bit
sound?
of video that we did. This was probably back about 6 years ago, actually. We've been doing it for a little while now. That same electronic leak detection on a nice sheet membrane install, going back and forwards over that rooftop. Found a few issues, closed them out nice and quick and easy, and happy days.
So you're finding it's pretty common, David, that you're going to be using multiple test methods per job.
Yeah, definitely. Um, Definitely. And I think that's part of the art and part of the value that we provide is the initial consult on, well, what do you really need, right? If someone called us up and said, we want to do every test that you've got, we want to be real sure, I'd say, well, I'd love the payment that would come along with that, but the truth is it's probably a waste of time. Here's
Yeah,
going to be your top five that are going to make an impact, and it changes significantly, internal, external, product type, the type of structure that you have. Um, yeah, hopefully that answered your question.
definitely.
Mm. Okay, well, moving on to the next one because we're still in some of the most simple test methods here, and this is probably one everyone's familiar with, is ultrasonic thickness testing. Great way. We all know that liquid waterproofing membranes, especially, If you apply them too thin, there's problems. They don't perform as well. Their performance does correlate with the thickness that it's applied. And if you don't reach a certain threshold, then there's a fair chance it's not going to achieve the warranty period or the design life and so on. And you get a lot of owners checking these things after the fact. So making sure that you have the correct applied thickness is very important. And the good thing about ultrasonic thickness testing is that it's non-destructive. I had a question the other day, which I think is a very important one, is, well, how do you know that it's correct? Do you do any destructive tests as well? And the answer is that we do. We think there's value in knowing for sure that what your device is reading on the day, as much as we very diligently make sure all of our devices are calibrated. Our particular approach and the reason we're able to get NADA accreditation for the consistency is that whenever we do ultrasonic thickness testing, we always do one destructive test first, measure it with vernier calipers, and then do that comparison to make sure our gauge is on point. And for anyone thinking, well, hey, well, you've just put one hole in it, you shouldn't be putting any holes in it. We always do this after we do our electronic leak detection or similar continuity test, and we always find at least one breach, right? Something that needs to be repaired. So a smart inspector will do the destructive test right at the location which already needs to receive a repair, so that then there's not any effort lost or quality loss that was not already requiring that repair. You have any thoughts on this one, Byron?
I think it's a good shout because, or part of what I do as well is that I've got an ultrasonic device. I don't go out there and do testing like membranes like you guys do. We sort of work, with a small range of clients who are engaging us to really incorporate their own compliance system into their business. And it's some people are like, well, how can you actually measure the continuity of the membrane just with a dry sonar device? And I'm like, well, it's an indicative test. It shows some due diligence. You use it over a whole range of different locations on the area and you work out an average of what that membrane could be or should be. Okay. And your main correlation here is to line it up with the manufacturer's technical data. But I think for categoric evidence, you really need to do the ELD testing, if you've got a scenario that allows you to do so. But the dry sonar device is definitely a device that helps to provide some assurity that we're near the mark of where we need to be in terms of the membrane film thickness. Now, final thing is just to provide some, further guidance to the viewers, David, is are you using this device solely for liquids or are you using it for sheet membrane as well?
Mm. That's a good one. Don't use it for sheet membrane at all.
Yeah.
Sheet membranes are prefabricated to a certain thickness. Never hurts to every now and again grab a piece before it's installed and chuck some vernier calipers on it just to keep the manufacturers honest.
Yeah.
But we've never found enough of a concern that we think that it warrants the effort of applying that. I did just want to build on a little bit what these standards cover and the standards that we apply, because it's a good question, right? If someone told you that, they went out and they chucked the probe down and they did one test on 1,000 square meter rooftop, anyone here that's listening now will say, well, that's obviously ridiculous. Like
Yeah.
there's no way that's representative of the entire area. But then the question becomes, well, what actually do you need to do to get something that's representative of the entire area? And not have it open to dispute by someone that just has a different opinion. And that's where standards come in. They tell us exactly based on the size, how many tests we need to do, that we need to, how we space them out, that we take 5 tests in a certain zone, we average the thickness of, and then we repeat that into the future, across the remainder of the roof. And that's how you get really robust, high confidence outcomes with this sort of testing.
So is it the ASTM test, from my conversations around the traps, you would be let's just look at this example up on the screen where you've got Anthony there doing some testing. Um, let's just assume that's a 20 square meter rooftop, which it would probably be more. How do we get an average? Are we using a 200, you know, millimeter square radius, taking four samples and then working out the average, like just, without giving all of your IP away, like, what does that look like?
Yeah, so I actually took that photo there. Shout out to Anthony Bissett, who leads our team in Victoria. This was actually on a rooftop. We're engaged by a strata committee, owners committee, several years after they were having some issues that were sort of arising, and they were concerned it wasn't lasting as long as it should. So we got up there, did a whole range of tests, including thickness testing. The thickness wasn't as good as it should have been.
Yeah.
The rooftop was about 500 square meters or so. And what we would do is normally assess that, measure the rooftop, break it down, follow the standard one batch of tests. A batch is 5 tests done in a 1 meter square area, and then averaged out. So we do apply one batch in the first 50 square meters, and then another batch for every 100 square meters after that. And then that's how we get it.
Yeah. Awesome. Nice, mate.
Excellent. Okay, so this next one is extremely unique, actually, but it's also quite simple, and I didn't want to spend too much time on it. A lot of you have probably not seen this before. This is very unique, specialist device. A lot of probably people aren't aware that while we do a lot in the resi market and commercial market, we also do a lot of infrastructure work. And this device is called a needle gauge for seam testing. Now, when you do below ground work and tunneling work, that's often done with sheet membranes like PVCs or maybe other types, and you use a special robotic welding device. It doesn't just weld a single overlap like you're probably familiar with on rooftops. It welds a dual run and leaves an open channel in the middle of it. What that allows you to do then is, after that long run of welding has been done, you can clamp both ends, put this needle in, and it works like you're getting an IV into your vein, and you pump it up full of air. And if it holds air, then you've got an airtight, watertight double weld on there.
Yeah.
So kind of a unique little interesting one that probably you're not going to come across on your average project. Cool. So that was it for all of the basic ones. And now we're going to go into the more advanced inspection testing services. So this one here, it is relatively common, but I thought it was sort of not an everyday like the others. So I put this into the advanced, and this is coating adhesion test. The same way that we discussed before, that liquid membranes specifically, and some sheet membranes, that their performance correlates with their thickness. It also correlates with how well it's bonded to a substrate. This coating that you can see on the screen here is a trafficable coating in a car park. If it were to have issues bonding to the substrate and it was to delaminate, it's now going to be substantially weaker and will fail much, much sooner than it would when it's supported and bonded to a structural substrate, right? So this sort of test is something you want to do at the time of installation. Ideally, in the early stage, get some prototypes down, make sure everything's going to plan, because adhesion's one of those ones that sometimes you think you've covered all your bases, but maybe there was some latent surface conditions, some moisture, something like that that's thrown it off. You want to know as soon as possible so that you can adjust your installation method and get that bond that's going to help it perform through your warranty period. You familiar with this one, mate? Do you have any thoughts on it?
I am familiar. Um, yeah, my thoughts are, is there a certain time frame you need to wait post membrane install before you can do a test such as this?
Yeah, you want to achieve full cure, right? And one thing I should have had a slide in here to explain the different types of failures you get with it. It can fail at the where the dolly is glued down to the membrane. It
Yeah.
can fail with the membrane bond to the substrate, or it can actually fail in between the layers of the waterproofing membrane. And that will especially happen if you don't allow it to cure and reach its full internal tensile strength.
So you see some exposed applications where some manufacturers would state you can have a one coat system, which is just laughable, okay, for a liquid. But then we see some manufacturers requiring 4 or 5 coats.
Hmm.
Now, my mind thinks it can be hard to achieve two for an exposed application, generally around weather conditions. Now, when we're trying to install 4 or 5 coats, I would think that's really hard to line up and to guarantee that you're not getting some level of contamination through the system compatibility chain.
Yeah, I think you're definitely right. And this is a term we use quite a lot. And I encourage everyone to take this away and build it in as part of your thinking. And it's called system fault tolerance, right? And I'll explain that by saying if you know you've got a two-layer system, and that means you need to have one good day of weather,
Yeah.
followed by another good day of weather with no rain or dust storm or whatever in between that would contaminate your layers, right? And then you have a four-coat system where you need to have, let's just say, 4 days with 4 days of good weather and nothing in between overnight or whatnot. Which do you think has a higher chance of something going wrong? It's got to be the 4 day, right? Because weather comes when it comes, things change when they change. The more you leave yourself open to exposure, the more likeliness there is something go wrong. So that means that has a lower fault tolerance because you're just susceptible to more of these things, um, is one way of looking at it. So I think the reason I'm conveying this is that materials aren't all created equally, right? Um, the sales reps will have you believe one thing, but when you start installing it and you realize, oh, this is what's going on here. Now I understand. I couldn't, like, I actually do have to install it at 4 coats because it's so damn runny. And now
Yeah.
I'm exposing myself to all of these potential failures of these unknowns that could happen on a construct and can definitely do happen on a construction site, then that product becomes less and less attractive, or it should to you as the consumer for anyone
Yeah.
installing.
And I think that's where, the era of the consultant, okay, is used really to help support you make educated decisions.
Yeah, that's definitely the idea. We try to provide that value and insight and just help out wherever we can with
Yeah.
consulting.
Awesome.
All right, so moving on to the next one here, and we will come back to adhesion considerations, but I'm just throwing this in the change of pace. Um, Vacuum bell testing. I wonder how many people are familiar with this one, because it is a quite an old method, to be honest. And what you can see on the screen here, I wish I'd included a bit of a video of this being done, but that is a vacuum bell, right? The hose that you can see coming off it effectively sucks air out of that chamber. And you place it over a PVC or a sheet system like this, and you spray a little bit of soapy water on the welds there. And as you suck the air out of that chamber, if the weld has any breaches in it, air from behind the sheet membrane will start bubbling up through that weld and you'll be able to visually identify it. Now, that's quite a stressful test, right? Putting that amount of vacuum pressure on something is probably way more than you might experience on a rooftop. So when would we recommend you use this test? And the answer makes a lot of sense. It's water tanks. When you have a water tank, it's going to have what, 2 meters, 3 meters head of pressure. You need to make sure that your sheet system is going to stand up to that um, by applying a similar amount of stress during the inspection quality control phase, right? So that's what this test does. And we definitely recommend it for water tanks.
Awesome. We've got a hard stop at 8:32, mate. So we'll
No worries. I'll power through some of these a little bit. So coming back to adhesion testing is mortar adhesion as well. And you might say, well, hey, this isn't, waterproofing related. What are you doing this for? It's substrate. We'll agree substrate preparation is as important as the installation. So making sure you have a solid substrate, very important. That's what this is. Remedial project, surface repair. Is it done properly? That's what this defines, right?
Yep.
Um, Move on here. Concrete surface profile testing. Now, this is one that I'm kind of a bit shocked isn't taken up a little bit more, and maybe that's our fault that we haven't actually conveyed the importance of it and that we offer it. This tests the roughness of your surface, right? We know that not rough enough, bad. You won't get a good enough bond. Too rough, also bad because your membrane thickness is going to be uneven and so on. So how do you get that in a quantitative way? Well, there's actually devices that we can do. And this applies both as a pre-installation and if things go wrong, we can come and say, okay, well, there's a dispute here around where was it rough enough or not? Let's do a quantitative measure and see where that comes out. So that's a really handy one to know. Next one is rain wand facade testing. This one in particular has a very specific standard, AAMA 501.2. It's for curtain wall non-operable windows. The whole idea is simulation of rain events, right? That standard defines how much exposure for how long we should be applying this water. You can see on the device there's a pressure gauge attached to it to make sure that pressure is consistent. You can also see that there's a bar coming out and touching the facade. That's to make sure that you can't get too close to it as well. So, very standardized approach to stress testing a facade system construction.
And I think you raised you said something very poignant there, which was that the testing method should simulate the intended use of the area.
Mm, yeah, you're right. I think we've all seen a lot of those, things or had clients to say, well, look here, I'm putting a garden hose on it. It's not leaking. What's the, problem as a defense? Like,
Well, I'll
well,
give people an example. I had a client where they flood tested an internal swimming pool without scanning the membrane. And I was like, oh, talk me through that. And they said, yeah, well, we flood tested, it up to 200 or 300 mil. And I said, and this was in a large apartment complex, large pool, couple hundred square meters. I said, so how did that test mimic the normal use of that environment? Was the pool under full load? Did it have chlorine in there? Did it have all the other, people and all of the other things that might, impact the workability of the membrane or the life cycle of the membrane? He said, no. And I said, well, it's not feasible to fill the whole pool up to do a flood test. You're not going to do that. But I think this is where you use a combination of methods where you give the membrane a scan, ELD, concrete substrate reinforced, so able to do it. You identify any membrane continuity issues, and you could still use that combination approach of a flood test like they did do to be more categoric. And they did it. And then tiled it, and I went, well, you
yeah,
know,
I think that's really good advice. And to sum it up is what is a defensible amount of rigor?
yeah,
And that's what you want to be aiming to achieve. Otherwise, you're just serving it up to your critics on a silver platter to come and pick you apart later.
yeah.
Um, so yeah, next one's really quick. Slip resistance testing. I'm not an expert on this, but we're all familiar with it. Um, People don't like falling over on slippery surfaces, and significant litigation can happen with it. The reason we've included this is it often comes off the back of exposed trafficable membrane systems that need to achieve a slip rating. And this is worthwhile considering. So we wanted to build it into our service portfolio for ease of access for our clients. Anchor pull-off testing. Um, so we introduced this it is most commonly used for these fall arrest anchors. That's what that is showing there on a rooftop. You can see the waterproofing's been detailed around it. But the other reason we introduced it is that a lot of waterproofing systems, especially sheet systems on exposed rooftops, do require mechanical fixings into it. And doing quality control on making sure those are achieving the required uplift rate and whatnot is something that's important part of that process. So we have adopted this as well. So it works for both the anchors on the rooftop. You can get us to do those after they've been detailed, and for any of those systems that are structurally fixed solutions. Now we're into the diagnostic testing services stage. So I think we're making some pretty good time here, but I'll move through at a reasonable pace because I do have some cool videos that I want to show you guys. Um, Very first one here is our second variant of electronic leak detection. This is something that's known as vector mapping. It's been around for a long while. A couple of different companies apply it. There is a standard to follow for it. And this one's quite interesting. It's not as simple as what I'd explained to you earlier with the metal broom, which runs over, and when it goes off, it identifies it because that's right where your broom head is sitting. This one's a little bit more mathematical, and it requires the entire surface to be wet. You set out a perimeter wire around it. You run an electric current through it, and effectively the wet area plus the perimeter wire creates a charged plate across the entire surface, right? And then what the device on the screen here does is measures earth leakage, is a simplistic way of explaining it. And when there's earth leakage at a certain point, one of those two poles is going to be closer to that point. So if you move these two poles around, and then that starts giving you an indication, sort of a hot and cold, and you can move around and then sort of trace it back to the point by doing this sort of simple maths of which one's closer. And then you can, yeah, trace it back, mark the point, and get it rectified. We don't do a lot of this one just because we find it a little bit cumbersome, getting the entire area wet. When you do have multiple breaches, it can be a little bit confusing about, okay, did I already identify that one, or am I still getting a reading from that one over there? But you know, is quite useful. And can be used in scenarios where you have a build up over the top of it, such as pebbles or that sort of thing, because it relies on the water to conduct. This one here is very similar, but it's what I'd consider the newest generation of that same technology, and we call it electromagnetic scanning. Bit of a unique application that I'm showing on the screen there at the moment, but effectively this is a water ingress point in a basement. That device there is just sort of the probe head. I'll show you the rest of it later. But that device there is now connected and earthed out into the ground outside the structure. And it's allowing us what we'd use this for on some projects that I shouldn't name for large infrastructure projects. But it allowed us to sort of backtrace through the structure where the source of the water was actually coming from, whether it was some sort of source inside the building or whether it was outside. And that's quite useful for that. But this is what it looks like on its day to day. We effectively have this trolley that runs across the surface. Again, this one requires the surface to be wet. What I'm not showing you in this particular photo there is that in that case is actually a laptop with a screen. And the reason we love this is rather than the situation with the previous one where you've got this hot cold sort of thing, it has this continuously running graph which shows you whether you're moving further or closer away from it in a much more informative way. Also, the way that this device works allows us to have a much higher precision and confidence in testing through things like a pebbled rooftop. a tiled area as well, as long as we're able to sufficiently saturate that buildup, or anything else, gardens, landscaped areas, that sort of thing. As long as it's not sort of too thick, then we're sort of going to have a bit of difficulty in, actually locating where the breach is that needs to be identified. But really cool, very expensive technology, but you get what you pay for in the precision and the results it's able to determine. Love this for remedial engineering firms that are trying to get an outcome and saying, hey, owners, you've got these breaches here based on our flood test. We really think you need to pull this up. And the owners say, give us more evidence. We don't believe it's that bad. We've done
Yeah.
a lot of this in that scenario. I explained this one to you before, or is this the first time you've seen this one, Byron?
No, it's the first time I've seen you present it. And it'll be something that I'll be leaning on you guys for moving forward because we
Yeah,
will.
it's a bit of a miracle technology. I think we've sort of kept quiet a little bit because we've been learning it, making sure we understand all its strengths and weaknesses and so on. But we
Yeah.
want a lot more people to be able to benefit from this. Okay, next one, kind of an obvious one. I'll be quick. Thermal imaging, right? A lot of you have probably played with a thermal camera before. Thing to remember about thermal imaging is it does not find water. What it does is identify thermal variance that can be caused by the presence of moisture or water because it's almost always undergoing an evaporation process, which is an endothermic process, and shows up something like this. Now, to make it a little bit more interesting, we go into drone thermal surveys. So again, something a little bit new. We've done only a couple of these, not something we've really even advertised. It was by special request that we got into it. Me being the person that is interested in all sorts of technology and just wants to find out whether we can make it be useful to a project. Acquired a couple of drones, have done a couple of good projects, very useful in the same way that the thermal camera is. Identify temperature variance, um, indicates water, then do some further testing to confirm the actual presence of moisture. So just a little bit of a video here of the sort of things. Unfortunately, it's not in thermal, but cool little bit of a view of one in Sydney here, looking at a rooftop system. So yeah, staying on the topic of drones, however, is something a little bit more elaborate, and this is something we call facade condition assessment. And we've got a nice little graphic on the right-hand side here, which sort of shows all of these things, right? Crack, crack, crack. If this was a glass curtain wall, it would identify things like deteriorated sealant, does a combination of thermal and optical. And the coolest part about this technology that we've just somewhat recently going through the process of acquiring the license for this technology is that it's all AI backed, right? So you imagine doing a very large building, the amount of time it would take for a person to sit through that, look at all the images and pick them out. Well, now one of the AI innovations is that they can do optical recognition of these sorts of things, compile a report which outlines all of these, in a nice graphical representation and gives a condition assessment, right? Facades don't last forever. They need repair and maintenance. Do you just wait until it fails and then try and get abseilers out there and redo the whole thing? Or do you, as the asset owner, do things proactively, identify and resolve before you're not only fixing your facade, but all the consequential damage? So that's a really cool technology. And unfortunately, I don't have a nice video to show you, maybe in the future. Next one, I do have a video, and this is a really cool concept. For years, I was thinking of this problem of, well, it's so common that you get these like unresolvable, where's that water coming from? It's dripping right here, but the membrane's flawless above. Like, what's going on? Wouldn't it be a great idea if we could somehow backtrace it? We know where the water's coming in, but we don't know sorry, we know where the water's presenting inside the building, but we don't know where it's actually breaching the envelope. So I thought about it for quite a while, and after a bit of research and some dead ends, found this tracer gas method. And this is something that I've adopted from plumbers. Actually, it's common for plumbers to pump gases into pipes and then use this type of technology. Well, we adopted this and sort of reworked it, reverse engineered it to apply uh, to apply it for a waterproofing remedial diagnostic scenario. Now, I'm going to play this video because it's pretty interesting. Byron, can you just confirm for me if you can actually hear it? Otherwise, I'll narrate.
No, we can't. You're gonna have to stop sharing and then share with sound.
Is that? I'm happy to talk through it.
I can't hear it.
Okay, I'll just mute it here. So then there is captions on the bottom there for anyone who wants to read. This is a great temple near Wollongong, the Nantien Temple. They have this big grand staircase up the top of it. This was all recently redone. The waterproofer actually done like an incredible job, and that's why it was so baffling that the gift room, which is located right below these stairs, was getting water leaks into it after all of this awesome work and retiling and everything that was done here. No one could figure out where it was coming from. We'd actually done ELD testing as the membrane was being installed. So there was a high degree of confidence, but still a lot of uncertainty there. So that's when we thought, okay, this is the prime example where we've got to do a real test run of this now. We got to figure out where the water's coming in, right? And there was this big stainless steel box gutter all the way through. Common sense would say, well, yeah, that's where the water runs to. It's going to be leaking from there, but we couldn't for the life of us find it. Flood tested everything. So I'll skip forward a little bit so as not to bore you. We came in from the underside. And keep in mind, this is called a tracer gas method. What we did was go up into the roof. You can maybe see a little bit there. I will go up and have a closer look in a moment in this video. But there's a crack there, and that crack in the structural slab is where the water was presenting. So what we did to the best of our ability was seal up that crack, and then we drilled an injection port in there, and then connected our gas tube. It's the yellow tube just off to the side there. And we started pumping our tracer gas into the crack. And the logic is that if water is able to flow one way, the gas under pressure should flow back the exact same way, right? So we applied gas to it, and then you might ask as well, okay, the gas is coming out. What are you meant to do? Smell it on the other side? And the answer is like kind of yes. This is a sniffer device that's intended um, to detect hydrogen molecules. And just for those of you that sort of say, well, hold on, isn't hydrogen flammable? Like what's going on? There's some incense burning just over there. It's only very small quantities of hydrogen, but this device is so sensitive that it will detect even very small trace amounts. So this is what we're doing. We're sniffing around anything that we could see as a weakness where the gas might be coming back through. We're finding nothing for quite a while here. Spent the full day on site until at this point here, it was quite windy, unfortunately, at the end of the day. But we ended up finding the issue, and the device, you can see that's it. It's getting a reading there of those hydrogen molecules. And what we found was that this one post at the end of the gutter had an irregular shape compared to all the rest of them. So that when the waterproofer applied the same termination detail, there was actually a gap in it. And it was going down between the waterproofing termination and that gap against the post, getting underneath the sheet membrane. It happens with sheet membranes. And then going all the way back, probably about 5 meters horizontally before it actually presented through that crack into the gift shop. So pretty cool one.
Yeah, awesome one. And Heinz made a good point. You know, wonder if you could use smoke as a method of testing as well in a similar scenario.
Yeah, well, I did look into that, and smoke is a common one for like facade buildups, and it's really good because you can visually identify it.
Yeah.
The reason why I didn't have sort of too much success with it is sometimes these cracks are very small, and even the smoke wasn't as small as the hydrogen molecules that actually forced its way through it. So I do think you'd have some degree of success with it, but we just found a higher a degree of certainty with this particular one. Uh,
Awesome.
and that brings me to the end of everything. So yeah, do you have any thoughts, Bar? I'm very happy to do a Q&A for anyone that might have some questions after all that information.
Yeah, no, we've got a few minutes up our sleeve, so happy to stop sharing and bring everyone back on. If you've got any questions, feel free to unmute. It's pretty quiet in the chat tonight, so maybe everyone's going to sign up to the Q&A session at the end of the series, which I'm sure David will willingly, without notice, put his hand up to participate and answer your questions. Through the remainder of the series, we would have gone through internal, external, and below grade waterproofing. Is there any questions? Feel free to unmute yourself, type it into the chat. We'll hold on for a little more. So for those of you who are unsure what we're talking about with the Q&A session, so we've got very informative from Rick Virtue. Thanks, mate. Got a question there, Rick? I think he might have just bailed. Um, so everyone's a little bit sleepy at the start of the series, which is fine. So for those of you who aren't aware, we're going to have a Q&A session at the end of the series, Tuesday, July 14th from 7 to 8:30, dedicated Q&A on the whole series. So Craig's going to put a link into the chat. If you haven't signed up for it yet, you can.
Links in there.
Awesome. Greg, how are you, mate? Can't hear you, Greg. Can see you, can't hear. Unmute. It shows you're unmuted. Can anyone else hear you?
No.
I can't hear you either, mate. Not sure what's going on. Maybe type your answer into the chat, mate, and we'll address it that way. He's typing feverishly over there. Great presentation, David. And yeah, a very rounded. This recording will be on the YouTube channel, the Comply Build YouTube channel. Very robust testing portfolio that you guys have. David at Waterproofing Integrity, it's taken quite a while to get there. Congratulations on the NATA accreditation. And highly recommend you guys having a look in at what Waterproofing Integrity do, particularly to ensure you got membrane continuity.
Yeah, I appreciate it, mate. Thanks for having me on, and be happy to help out anyone or any projects that are in need. We just want to bring solutions and value and confidence that no project comes back to haunt.
So Craig's just put a link to the YouTube channel for Comply Build. So click on that, like the page, then you'll get notifications when new videos are uploaded. We'll definitely be putting this on there. You'll be able to contact David through us as well. So we're more than happy to pass leads on. We're not in the habit of doing all these robusting testing. We help companies develop their own compliance layer and the quality control software to get the documentation up to speed. We work in with waterproofing integrity from project to project, probably more so moving forward. Get involved, ask questions, reach out to us. We're here to help. When we formed the events across the Eastern Seaboard for Construction Connect, it's because we were fed up that there was not enough going on around industry and there was a lot of bullshit floating around. We are independent consultants. We work on the ground face. We try and provide real solutions, no bullshit, help you to navigate the complexities of the code, standards, product manufacturers, requirements to get successful outcomes. It's what we do, we care, and we want to help you minimize the risk of failure. We work hard for our coin. And so, moving into a different era in the construction industry where we need to really dot our I's and cross our T's. Looking forward to series two. It's going to be a cracker. I believe most of you have signed up to. Sorry, I've just kicked my cable out of the power board. I believe most of you have signed up for the whole series. Highly recommended. If you haven't got a Q&A pass, then I highly recommend you do that as well, because that's where the real power is going to come from. Send your questions through and we'll address it at the end of the series. Greatly appreciate everyone's support. David, once again, a big thank you to you and Waterproofing Integrities for your support of the series, and please reach out. So, Craig, good on you, mate, for hanging on, and everyone, we'll see you next week. Thank you very much.
Cheers. Thanks, David.
Thanks, everyone.